Still got to
recording. Oh, Jane, you built a dead hedge. Fantastic. Yeah, Amy, a bit overwhelmed with all the new info, but excited. You're going to book in a session with Esther. That's brilliant. So for those of you who don't know, Esther's our Team Wilder ecologist, and I think she would have told you possibly on the first session that if you want any advice specifically on your garden, you can book in an appointment to have a chat to her. So just look on our website and you can find out about that. It's excellent. Okay. Cool. So it will be exactly the same deal as the previous 2 weeks. Alex is going to do 2 sort of presentations with a little bit of a break in between. First one's going to be on soil. The second one's going to be on compost, both like amazingly important things that are like the foundation of building an amazing garden. What we'll do is Alex is happy for you to just unmute and ask a question if it's sort of on topic to what he's talking about, or put it in the chat, anything that you want to ask that's related to the topic, and I will read out those questions for Alex.
Thank you.
Cool. Just before we start, oh yeah, Maria's planning a rain garden. Oh, and a pond to a bog garden. That sounds amazing. The Word doc from week 1 resent. Yes, I will just make a note to do that. Aidan Jen. Send Word doc from week 1. Okay, right. Well, with no further ado, I am going to pass over to Alex.
Hello, good evening, everybody. Thank you for joining me on such a gorgeous evening. The temptation to be outside in the garden is strong, so thank you very much. Really, really pleasure to meet you all. I'm here to talk to you about my favorite topic, which is soil health for gardeners, and particularly my number 1 topic, which is compost. I'm a big believer in the importance of composting, and by the end of this, I hope you all too will be super excited about getting your compost built. And you won't know which one to do first, your pond or your compost bay, because there'll be so many ideas and you want to do them all. So the way this session is going to run for me this evening, let me make sure that that's working. There we go. Is I'm going to do roughly about 40 minutes talking about soil. And in that, we're going to talk about what is soil, how it's the composition of the soil, kind of what you might want to look for, and how you're going to be able to find out what type of soil you have. But this is also a wildlife, but most importantly, this is a wildlife course. So one of my favorite things to talk about is the life that's in the soil, because soil for me is a living thing. It's not an inanimate thing. It's a living ecosystem. In fact, I like to think of it as a superorganism. Then we're going to have a little bit of a break. And then after that, we're going to come back and we're going to talk about compost. And by the end of this, you'll understand why these things are all linked together, because the compost and the ecosystem and your plants, it's all together. It all makes sense at the end, and like kind of the links all links all together. Can everyone hear me okay? My sound okay? Brilliant, fantastic. So I'm going to jump straight in with a question to you guys. So anyone wants to kind of unmute, or you can put it in the chat and we can feed it out. I guess I'd like to know the question, like, what do you think I mean when we talk about soil? What are the words that kind of come to people's minds? Has anyone got a kind of any thoughts that kind of jump out and what is soil? What are we talking about? And what is healthy soil, perhaps? Anyone want to be brave, unmute, and maybe join in the conversation?
Yes, I think it's a living organism networking.
Yeah, brilliant. That's perfect. Anybody else? Yeah.
Lots of worms.
Lots of worms. Worms are my favorite thing. Absolutely love worms. Anybody else?
Amy said peat-free soil, and Mo has said the earth.
Yeah, love those things. We're going to talk a little bit about peat and why it's important to keep that in the ground. But yeah, peat, we will definitely be avoiding peat in our compost. And the earth, the earth is, the Gaia, our mother. It's the support system for everything, isn't it? So thank you. That's some brilliant answers. Is anyone inspired by the Cambridge Dictionary definition of soil? the materials on the surface of the ground in which plants grow. No, it's not exactly the most, it's not the most engaging definition. And I think it completely misses the importance of what we're talking about. And I prefer this thought, which is that we owe our existence to the top 6 inches, to a 6-inch layer of topsoil and the fact that it rains. Everything on Earth is dependent on healthy soil. All human existence, all our non-human friends, everything comes back to the soil. And that's true even of water systems. And I love a Japanese quote, which is, if you want to catch a fish, then plant a tree. Everything is linked together, and it starts with the soil for me. I think, given that this is a wildlife course, I'm making the assumption that we all want to kind of look after our gardens and look after our environment in organic methods. So we're not using inorganic fertilizers and we're not using pesticides and herbicides. So in the UK, what's the name of the organic certification? It's the Soil Association. It all comes back to the soil. So it's really, really, really key, important thing to think about. Is where everything kind of comes from. If anyone has any problems reading my slides, I hope they're nice and clear. So basically, I've kind of gone for a no bells and whistles, a very simple PowerPoint presentation with very few, very little text to make it nice and clear. But please ask any questions if you have any. So healthy soil supports the growth of our plants. Healthy soil is full of life and it feeds the ecosystem. It's the start of all our ecology. Healthy soil is more resilient, it holds more water and needs less inputs. And knowing about your soil helps your plants be healthy and basically reduces the amount of work you need to put in. So understanding your soil is kind of a key part of horticulture. But even if you're doing a wildlife garden and you don't actually want to interact too much in it, it's going to make your life a bit easier if you understand what's going on in your soil. So soil is made up basically minerals, organic matter, which we're going to call soil organic matter. And the organic matter can be everything from the living roots that are in the ground, leaves, the microbiome, so all those microorganisms, our fantastic worms, the most amazing creatures on the planet. I absolutely love them. We'll talk a lot more about them in a bit. Water, and a surprising amount of air. A living soil, because it's a living organism, needs the same things that you and I need. It needs water, it needs air, and it needs food. If we think of it as a living thing, it becomes quite simple to look after. We just need to feed it. We need to make sure that it can breathe, and we need to make sure that it's got the right amount of water. So where does soil come from? Well, soil can take a long time to form. And you might hear people talk about how it can take 100 years for a centimetre of topsoil. But also it does actually form quite quickly. Here's a photo that I took maybe 2 weeks ago, a place in Wales. Some of you may have heard of it. It's the Centre for Alternative Technology. It's CAT. And it's up until the 70s was a slate quarry. And it was completely desolate, complete waste ground of slate. And here we can see the formation of a woodland. You can still see the raw slate there. You can see the mosses and you can see the trees forming. And that's kind of how, to me, it is a good illustration of kind of maybe where early soil starts. You kind of got the mineral composition, which is coming from the slate and the wider environment. It's getting trapped in the pores between the slates. And then the mosses come and the mosses trap more. And the mosses feed the life that then lives in that soil. And then bigger plants can get rooted. And those bigger plants trap more organic matter, and it all starts to build up. And over time, we get our layers of soil. Ultimately at the top, oh, hello. And that builds up into what we kind of think of as the soil horizon. Is that clear? So in our picture here that we're looking at, we've got the soil horizons, and the bedrock in that previous picture would be the slate. That slate starts to break down into the parent material. As it's broken down into the parent material, stuff like originally the mosses would start to form, and that starts to help break that down and starts to accumulate. And as the buildup of organic matter comes down on top, we get the organic layer, and that's the humus, and that's the top 6 inches of topsoil that supports all of our plants, all of our food. It's where most of the life happens. It's where all our worms live. It's where all of our well, lots of slugs. It's where all of the life happens, basically, and it's what we need to support life on Earth. It's responsible for a lot of the purification of our water, fresh air support, etc. So this image here kind of shows you how over time those layers build up from the bottom up to the top and from the top to the bottom. And sometimes when you see really, well, if you go to places where there's been a big rock slide, or if you think of where there's been big buildup of soils over time and they degraded. So for example, the Grand Canyon, you can see those different layers where there's been a buildup of humus, then another layer on top, and it gets pushed down and it continues to grow at the top. So thinking about soil and what it is as we described, it's a living organism, but it's made up of its physical properties. So that's the sorts of stuff that you will talk about when we think about, is it a clay soil? Is it a sandy soil? Is it a silty soil? Does it have, what is the pH? Is it an alkaline or an acid soil? That's also linked with the chemistry. So the chemistry is the pH, the nutrients in there. So we've got nitrogen, potassium, phosphorus, and then there's the biology. And all of those things link together to kind of build your soil that's specific to your location, with the correct climate, with the water that you get, with the shade that there is, with the plants that are living. It's all linked together. So the soil in your garden is unique to your location because of the specific climate and the specific soil properties and the chemistry that comes with that and the biology that comes with that. So I think in the first week, you looked at an online tool for looking generally kind of at kind of a regional and kind of semi-local way of seeing what your general soil properties would be like. But it's really helpful to know what's going on specifically in your back garden and in your space. So understanding those properties is really key, because it'll give you an idea of how is that soil going to behave. It also means that you can, when you go to a nursery like the Grow Wild Nursery, you can look for plants that are going to be specifically tuned to your types of soil. So plants that would like a sandy soil. Maybe you think of stuff like herbs like rosemary and thyme. They're like kind of free running sandy soils. Or you might have very alkaline soils, and then you're looking at plants that like those wildflowers that like those alkaline soils. So understanding that is kind of really key. So I guess what I'm going to talk about next is kind of how we would find out what you've got. As I said, we've got clay, silt, sandy type of soils, but we've also got organic soils. So the organic soils are, as we mentioned earlier, the peat soils, for example. And those are soils that have built up over millennia, hundreds of years, thousands of years of organic matter, specifically mosses, that because of the particular environment, because it's really wet and cool, they don't biodegrade, so they kind of just build up and the organic matter builds up. So peat soils up in the highlands, or where we've got drained soil. So in the fenlands near Cambridgeshire, for example, where we've drained the land, and all that all the living organisms that were in the water, all that the organic matter that was in the water is kind of settled, and that forms the top layer. So pure organic soils. Inland in Bristol, we're not going to get a pure organic soil. We're looking at mineral soil. So that's kind of your clay, your silt, and the sand. Is there any questions in the chat? Is everyone clear?
No questions so far, but appreciation for your clear slides.
I hope so. Thank you. I'm not one of those people who makes lots of PowerPoints. I'm usually happier out in the field, growing vegetables and digging holes. And so it is fun to make some PowerPoint, and I'm glad that I've held it back and I've not got too much animations. So when we talk about sand, silt, and clay, specifically what we're describing is the physical particle size of the particles that make up your soil. It doesn't describe what the parent material was, although the parent material will ultimately result in a different type of particle size. So for example, this is to do with geology and the formation of how rocks are made and how they break down. So for example, on the slate is made from fine particles, and as it breaks down into fine particles. So slate breaks down into clay, for example, whereas harder rocks don't break down into such fine material, and you get larger particles, and that could be your sand, for example. So the description, clay, silt, and sand, is specifically a description of the particles. And you can see on my slide here how much bigger the sand is. And we all know sand, we can see it with our own eyes, and we can particularly feel it. So in a moment, we're going to talk about how you can find out what type of soil you have. And the key thing for me is touch. It's about feeling and being connected, paying attention. Sand is very coarse. You can feel it with your hands. You can see it with your eyes. Silt is somewhere in between the silt and the clay. Clay particles, when they're completely dry, it's fine like talcum powder. If you were to buy clay powder clay as a dried powder, it is like talcum powder. And when it gets wet, it sticks together and it clumps together and it forms that amazing kind of unmistakable texture. It's really smooth. Pure clay is completely smooth. You don't get any texture from it because the particles are so fine. Silt is somewhere in between, and you can see kind of there's an illustration there of the size particles difference. There's another picture here, how much bigger the sand is. The silt is kind of somewhere in between, and the clay particles are completely, you can't see it with the naked eye, but they clump together to form the clay that we experience. And that's to do with the kind of the physical properties of those clay particles, because they're so small, they bind together. And because they bind together, that kind of affects how they behave in your soil and kind of dictates your soil properties. So the next slide, don't freak out. There's lots going on there. You don't have to try and remember it, because I'll be supplying a PDF document which will have this slide in there, the description of how you can test your soils. So I'm going to call the protocols, the way that you can go and test your soils, and there's 3 different ways. That's all in there and going to be in the PDF, and any other information, extra resources, etc. So don't panic too much here. But basically, you've got the large particles on the left, that's the sand, and we've got our clay on the right. And the different properties of those soils. So we've got aeration. So sand, there's lots of air in sand because the particles don't bind together, and there's lots of voids for the water for air to be, but the water drains straight through it. So if you want plants that don't like wet roots, they like sandy soils. low nutrient capacity, again, they don't have much magnetism. So the nutrients, the nitrogen and phosphorus don't bind to the particles. So again, they can leach out quite quickly. If you've got very sandy soils and you apply a liquid fertilizer, it just flows downhill, that with gravity. Temperature, they'll warm up quickly in the spring, but they also get cold in winter. At the far right, clay is the opposite. Clay, we've got poor aeration because the particles stick together, but the water capacity is high. So if you've got clay soils, actually, if we manage them well, can be really good because they hold water, they hold nutrients, usually a fairly neutral pH, although it can be a bit more acidic. It's slow to warm up, but slow to cool down. So it can be good for plant growth into the later part of the summer. It can be prone to what's called capping, which is basically where if you put too much weight on there or you disturb it too much, all those clay particles stick together. But most of our soils in our gardens aren't going to be a pure clay, and they're not going to be a pure sand. It's going to be somewhere in between, as a combination of everything. And we may have heard the word loam, especially if you are looking up to buy topsoil. A lot of people, it will describe loamy topsoil. Or if you go to the garden centre and you want to buy some compost, if it's a soil-based compost, it'll describe it as being loamy. I'll come to that in a moment. But loam is basically, it's not a description of a particle size. It's not a separate thing. Loam is this kind of in-between stage where it has something of everything. So it has all the benefits of clay, good water retention, good nutrient retention, but it has some sand in there. So it allows for aeration and allows for some water to drain. So a good loam is a kind of a combination of all of those things. And that's kind of what we would love in a vegetable garden, for example, or a highly productive flower garden. But if you've got a garden which has a very sandy soil or a very clay soil, don't despair, because in nature, plants have adapted specifically to cope with those situations. And what we need to do is kind of think about what grows well in those environments. And here's this picture here, which is Prospect Cottage. This is Derek Jarman's garden, and that's Dungeness. This is a beautiful garden, literally on a beach. And we can see here, this garden is full of plants that we may not even think that would grow well there. But Derek was a really great gardener because he loved to observe and he loved to see what would grow. And he was observant of the wider environment. So he looked for soils, looked for gardens that were similar to his very pure sandy beach, or found plants that were growing in the beach and moved them to his garden. So if you've got pure sand, you can still grow a beautiful garden. So for me, the best thing to do to find out what type of your soil you've got is to get in there and get your hands dirty. So I recently moved into a new house, literally a couple of weeks ago. I've been so busy because I got a 1-year-old that I haven't had a chance to properly look at my garden, despite the fact that I'm a gardener and my wife is a gardener. We've been a bit too busy. So I've got some soil here, which I dug up today. And what I've done is I literally just took a trowel full of soil from one part of my garden, but I would do it in a few different parts as well. In one trowel, I've got 3 adult worms. I found some worm eggs. I found a baby leopard slug. I found lots of mites and all sorts in there, but particularly, so the first thing I did when I'm thinking about what type of soil do I have here, can you hear me all right, because I moved my screen, is I'm looking at color. I'm trying to think about the texture, and also because I'm a very it's all about my senses, I'm also going to smell it. I'm looking for the kind of I'm a big believer that intuitively we know what is good. If it smells sweet, it smells fresh, it is right. We can use our senses to find out that things are not right. For example, if it smells bad, if it looks anemic, and so if our soil smells bad, or this or the soil looks really, really anemic, really light in color, a gray color doesn't look that really doesn't look that healthy. If it smells bad particularly, there's something probably going on there. But the first thing I did is I want to get my hands in there and I want to feel it, and I can feel instantly that I've got quite a lot of sand in here. So I've got some pictures of what I did. And in order to kind of work out what I'm doing, I've done what's called the ribbon test. Some people call it the sausage test. That's a slightly different way of assessing what you've got. And also in our instructions, I've included what's called the jar soil texture test. So these are in the PDF, so don't try and read them, but basically they're kind of flow charts explaining what you're looking at, what it means. So this is the sample that I just showed you there, the picture that I took. And you can see there's lots of living roots in there. You might even be able to see a centipede, I think. There's a centipede or a millipede there. I zoomed in earlier and I can definitely see a mite in that picture, but I'm not going to expect you guys to spot it. So again, using a visual check, I can see we've got some clumpy bits. It's not a uniform texture. There's lots of different textures there. I can see some stones and I can actually see some sand with my eyes. So I'm using a visual check. I've smelt it with my nose. It smells really sweet. It smells quite fresh. But interestingly, I took another sample from another part of the garden right at the back near the shed, and instantly I smelt petrochemicals. So I know instantly that probably when they've been emptying the shed, they poured something like white spirit. They maybe it smelt petrol-like actually. The plants don't look like they've been too badly affected, but I can tell straight away with my nose that there's something going on there. So that's not good. So using the first method, which is the ribbon method, the first thing you do is you roll it up into a ball in your hand. You put a little bit of water on the soil sample, and you roll it up, and you're using the palms of your hand to feel for the texture. And again, with this, I could feel sand. It felt smooth, and you can see that my hand is a little bit muddy. That's the silty bit actually. That's some silt there. Clay, it would make it really smooth. But you can see there's some smooth bits there. It's a bit sandy. I can feel the sand with my hand, and I can make a perfect ball. If you can't make a ball, you've got pure sand. If you make a really perfect round ball with perfectly smooth, you've got pure clay. I then pushed it out into what's called the ribbon. So you could either do it, usually in the description, it'll tell you to push it out into kind of a thin, long ribbon. And the longer you can push it, the more clay there is. I've kind of gone out like this, and you can see it started to crack. So I can get it quite thin. So there's obviously a good proportion of clay there, but it's then started to crack because the sand kind of starts to break it up. The other method, which is the sausage method, is you roll it out into a pencil, and the thinner you can get it, the more clay there is. And when you get to about 15 centimeters, you then try to turn it into a donut. And depending on how far you can get to the donut, depends on how much clay you've got in there. I managed to get it all the way into a donut, but as you can see, it started to split. So based on my texture, my touch, and the two different tests that I've shown you there, I know that this is a sandy loam, sandy clay loam, basically. So it's basically got a bit of everything. I've lucked out and I've got a really good garden. Well, good potential for a good garden at least. So what that means is I can use my visual check. So the dark color suggests that there's lots of organic matter, and I can see lots of organic matter because there's roots in there. I've already found lots of worms. I've already found lots of small bugs. And I've got that loamy soil, which I want for good drainage, but I'm likely to have good water retention, etc. If I wanted to really know exactly what I've got, we can do what's called the jar test. And again, there's a detailed description of how you do this. But the jar test basically means that you take your sample and you put it in a jar, fill it with water, give it a good shake, and allow the particles to separate. After they separated, you then kind of mark on your jar, oh, there's my finger, that part's sand, that part's silt, that part's clay, and you do some maths, and you work out your maths against the mythical pyramid of soil mineral composition. And where your lines, 3 lines meet, it'll tell you literally exactly what your soil is. So don't panic, because the description of how to do this is in the will be in the PDF. I've got soil all over my laptop now. But this is the most accurate way of easily working out what kind of soil you have in your back garden. But my favorites is to get messy, basically. Get involved, get your hands dirty and feel what you've got there. And again, I'll return to this image. And that is helpful to refer to when you're looking at it, when you've kind of found out what your soil texture is. That kind of helps you then plan your decisions about what sort of plants you're going to plant, where you're going to plant them. Combine that, for example, with an understanding of the pH, which you do by you can get them from, just get them online. You can get a pH test, and that will give you a really good idea of the composition of your soil, and therefore what plants are going to thrive in that soil. Generally, we want a kind of a neutral soil that comes up as pH 7. Anything below that, 1 to 6.5, is acidic. Above that is alkaline. I would say generally in a domestic setting, but even on a farm setting, changing that acidity isn't particularly easy. But integrating organic matter, so integrating compost, is a way of what we call buffering. So by integrating organic matter, integrating compost, integrating life is really key here. We can basically neutralize it and we're creating that ecosystem, a place where our life is going to thrive. So you're unlikely to have an extremely acidic soil. You're unlikely to have an extremely alkaline soil, but you might have an alkaline soil of pH 8, 8.5, and you would want to look for plants that are going to thrive in that environment. Equally, it might be a bit more acidic. And if it's as close to 7, by integrating organic matter and by planting in there and trying to create an environment where life's going to thrive, actually it tends to buffer itself out. So you can actually have a thriving environment without worrying too much about soil pH. And I generally don't talk about it because it is something that we can't massively change, but it is important when you're planting. And again, if I think about that picture of Derek Jarman's beautiful garden on Dungeness Beach, in nature, we've got ecosystems that are particularly found at that niche. So alkaline soils are soils that have lots of calcium in it. So I'm thinking of the White Cliffs of Dover, kind of those really beautiful alkaline soils. And there are loads of beautiful wildflowers that thrive in that low nutrient, high alkaline environment. So it's really important to think about, maybe if you've got one of those environments, to try to plant for it, because a lot of those environments are niches for really important plants. The pH basically affects the soil's ability to retain nutrients, and also affects the biological activity. So, but the most important thing is life. So organic matter, that's the carbon, that's basically the food that feeds all life. We're all carbon based and we all need that carbon food. So by integrating organic matter back into our soil, particularly compost, we're feeding the life. We've got our worms, bacteria, our slugs. Does anyone know what type of slug this guy is?
It's a leopard slug.
It's a leopard slug.
My favourite.
My favourite slug. But we've got over 40 types of slugs in the UK. And the ones that eat, there's only a couple of them that eat your seedlings. So slugs are a super, super important part of the soil environment and a super, super important part of the broader ecosystem. So slugs get a bad name, but I absolutely love them. And for anyone who doesn't love leopard slugs, they're omnivores, and their favorite food is snails. So they kill the slugs that eat your seedlings. They kill the snails, but they're also a good food source for higher up the food chain. They just look beautiful as well. I think they're really beautiful. And actually, in my sample, I found a little baby one, so I'm happy. This cheeky chappy is a protozoa. Look how happy he is. We've got roots, living roots. What's really important is feeding our soil and feeding our soil with plants. So in nature, we very rarely get bare earth. So keeping your garden full for as much of the time as possible is really important, especially over winter. Don't be desperate to pull out your plants if you've got annual flowers, for example, and it comes to the autumn and they've died and they're not looking great and they're brown. Leave the roots in the ground, because that organic matter is breaking down. If you pull them out, you're taking away that food source. Then we've got all our I just gone blank for the word. Our tiny macrofauna. So we've got mites and all the spiders, arachnids, everything that kind of lives underground. Does anyone know what these guys are?
I do, but I'd like to give somebody else a go.
Go for it.
No, go on.
Please.
I was going to say, I think I do, because we have loads of them. Aren't there a grub for a kind? Oh, they're a grub of something. Maybe. I looked up at everything. I can't remember though, because they were grossing me out, so I had to find out what they were.
Are they rose chafers?
They are the Maybug. So whoever's speaking, thank you, because you summed up perfectly. They are grossing you out. They look gross, don't they? They are, and it's easy to be a bit revolted by them, because they look like something that should be on a bush tucker trial, don't they? They are big and they're juicy and they're gross and they're scary, but they're the grub of the beautiful may beetle, the rose chafer, that beautiful iridescent green beetle that should be I think I saw one today, but towards the end of May, certainly they'll be everywhere. They'll be on all the umbellifers, and they're great pollinators. They're beautiful. I think they're really, really interesting. And until fairly recently, a certain large horticultural charity was listing at the grubs as a pest. So it's really important to view maybe gross things like that. If they were listed as a pest because birds, badgers, hedgehogs, they like to dig them up and eat them. So they come into your garden, the badgers come into your garden and they dig up your bed because they're trying to eat the chafer bugs. Well, we're here. This is a wildlife gardening kind of course. So the point is that the life in the soil, it's not just good for the soil. We need it in there to feed our wider ecosystem. So stuff like the chafer grubs, they might be gross, but we need them. And actually, once you understand that, they're no longer gross. This guy is a tardigrade, which is one of the most indestructible organisms on the planet, and they live in every ecosystem. And there's a beautiful book by a woman called Robin Wall Kimmerer, and her book is called, well, she's got two famous books. One is called Braiding Sweetgrass, but her first one is about moss, called Gathering Moss. And she has a beautiful chapter about tardigrades and how they just bumble through the moss like a big hippo through a woodland, and they're just really cute, and they live everywhere. They live in water, they'll live in your pond, they'll live in your moss, they live on your grass. They live everywhere. This is a glassworm, so not a tree worm. Ants are super important. Again, it's easy to think of ants as a pest in your garden, but they're really important for soil structure. They're really important for aerating your soils, digging holes. They dig holes that then minor bees live in. So if you disrupt the ants and you try to get rid of your ants and you're poisoning your ants, or the reason why we think of ants as pests is because they like to they farm aphids on your roses, for example. But the aphids are food for birds. The ants are great for the soil structure. They're protecting their aphids, so they actually they act as a defense mechanism for the plants, because they have an incentive to keep your plants healthy, because they want their aphids to be healthy. So they attack anything that might otherwise attack your plants. So ants are super important for soil. Dung beetles. Until recently, we may not realize that we had dung beetles in the UK. One of the reasons why we don't necessarily have that many dung beetles is because of antibiotics and the stuff that we feed cows. But if we're really lucky, we can see dung beetles in our gardens, especially if you're near an organic farm where they've got cows and there's pasture. So kind of keeping an eye out for maybe those unsung heroes. One of my unsung heroes is woodlice. I know we're going to have a short break, apologize. But woodlice is super, super interesting. Again, many more species than you might be aware of, and they're really beautiful. And what I like to ask when I've got a group of people and we all come from different places is, does anyone refer to woodlice as anything other than a woodlouse? And you can put it in the chat or you can shout it out. Does anyone refer to woodlice as anything?
Always called them Charlie.
Anyone?
We've always called them Charlies.
Charlies, that's the first time I've heard that. I love that.
Yeah, my mum always used to call them Charlies. So we fell in love with them because they were called Charlies.
Oh, I love that.
We always called them grandfathers.
That's brilliant. Again, I haven't heard grandfathers before.
Yeah, someone else has just said cheese bugs. I'm from Kent and we call them cheesy bugs. Yeah.
Love that. My wife calls them chuggy pigs.
That's amazing. We've got slaters and
Slaters is really common. I love that.
granthers. And pill bugs. They're the ones that I call those ones, the ones that roll up. I call them pill bugs.
Apparently in Cornwall, they're called gramousals.
I really, really love that. And I think for me, one of the reasons maybe we have so many names for them is because they're so much fun for kids. And I've got a little daughter, she's just turned 1 and she's just starting to explore. She just turned 1, it's the spring, and she just started to really explore being outdoors. And I remember playing with woodlouse, although I've only ever called them like that, because they're, you poke them and they roll up into a ball and they're really visual and they're fun. And I've noticed that with younger people, if I ask them, they don't even necessarily know that they're called a woodlouse. And I think we're losing that connection, and that demonstrates to me a lack of connection with the animals and with our soil. So I love the fact that we have so many names in this group, because that's the most different names in one group that I've had. So thank you so much. But woodlouse, they feed on woody material, and they break that down into smaller bits, which mean it integrates better into the soil. So some stats there about how much life is in our soil, and then we'll have a quick break and we'll talk about composting, because there is so much life. Like we say, it's a living organism, it's a superorganism. 1 teaspoon of 1 teaspoon of soil can contain many kilometers of fungal hyphae, 10 billion bacteria cells. 1 square meter of healthy soil can have 300 worms or over. And there's a farm, it's near Cambridgeshire. And if you've anyone's read the most recent George Monbiot book, he goes there. This is Ian Tolhurst's farm, and they've been running a trial, and he's got over 1,000 worms per square meter. I mean, that's more worms than soil. It's just the ground must literally be writhing. And it's just amazing. And all that life is what makes soil be soil. So that talk at the beginning about the mineral content and the structure and the sand and the silt and the clay, that's really important, because that's the physical environment that we need to think about for our plants. But it doesn't become it doesn't support life until it's got life in it. And if we think of it in that way, then it becomes easy to look after, because it's the same as us. We need air, water, and food. And feeding it good food. You know, we don't want to be feeding it inorganic fertilizers. We need good sustaining food, and that sustaining food is going to be our compost. Should we call it a 5-minute break at this moment? Does anyone have any questions? And then we can go for a break.
Nothing in the chat. Does anybody want to add anything or unmute?
I was just going to ask a question.
Please.
We have raised beds. We live in rented accommodation, and we've got raised beds. With the kind of, you showed like the structure of the soil. Obviously ours won't have that, because there's going to be a point where it stops because it's on like a patio. Would we end up having to like change the soil, or would it create its own kind of microclimate within the beds?
It's making its own microclimate, because if we think of life as a single cell bacteria, if you've got a gram of soil contains 10,000 billion bacteria, from one end of your bed to the other side of the bed might as well be Australia. So it's building up its own ecosystem, but you're going to need to feed your raised beds. And what I'd recommend doing for that is, over time, what's happening in that bed is, what did you put in there? What did you fill the raised bed with?
Well, yeah, so the first year we dug it all out because it was just overgrown, and then we grew vegetables. We've got one side's got like bamboo and a bit of beech hedge and a passion flower and a jasmine bush and stuff. It's a bit of a mismatch. But then the middle bed where we grew vegetables, it did really well the first year, and then the next 2 years it just kind of got gradually worse, and we kind of gave up this year because we just weren't producing much.
So over time, as the plants are growing and all the life in the soil is living, they're breaking down the organic matter that's in that soil, and they're feeding on the nutrients that are in that soil, and they're feeding on the carbon that's in your raised bed. So you need to return that to your raised bed, because there's no natural way for that to happen. In a field situation, one way that happens is actually you've got all the mycorrhizal, all the fungi goes way out into the soil and brings it back to the plants. But in your raised beds, that doesn't naturally happen. So what I recommend is that you want to feed that. We're going to talk about this in the composting, is you want to feed that with proper organic carbon, so good quality compost. And you just put that on the top of your bed, and the life in the soil will do its thing. And you're mimicking what's happening in, say, in a natural ecosystem where the leaves and the trees are falling in the autumn, and they're falling onto the ground, and the worms are pulling it down, and you're returning carbon to the soil to start the new season the next year.
Great, that's really helpful, thank you. I thought that was probably the case, but I thought I'd check. Yeah, thank you.
The only other question, the only other point we've had here is from Julia. Oh, I've stopped sharing, by the way. May come to it, but I have mainly a clay soil, and worms seem to be very few and far between. Is that expected?
So there are specific worms that thrive in a really heavy clay soil, but with the clay, it binds so tightly that it is quite difficult for the worms to kind of tunnel through, if you imagine. But if you integrate organic matter into your soil, so again, we need to think about, what do worms eat? Worms eat, well, they basically tunnel their way through the soil, and as they tunnel, it goes in through their mouths. They don't have any teeth, and so they use sand in there to break down the particles, and basically they're feeding on the organic matter. They're breaking down stuff like leafy particles and small particles of organic matter, of the leaves and the twigs, and but they're also feeding on the bacteria, and they're basically breaking that down. It comes out the other side all kind of churned up. If you've got a pure heavy soil, pure clay soil, which you can imagine, instantly you kind of picture really tight, no air holes, and very little literally, I'm going to repeat myself, but the organic matter, there's also nothing for those worms to eat. So again, one way of dealing with that is you can dig in lots of compost or manure or leaf mold, and that's a hard physical labor. And if you do something like the RHS or the traditional way of looking at horticulture, you would do what's called double digging. So you dig it out, you put a load of organic material in, then you put it back, put it all back on top of each other and mix it around. Or you can layer it on top again. And the reason why I talk about layering it on top is because you'll start to get worms in that top section, and that becomes, if you imagine the image I showed of the different layers, the different strata, the top section is where all the organic matter is, and then your clay will be below, and you get lots of worms in that top section, and then they would start to kind of break down into the clay, and you'd get more roots going down, and over time your clay soil is broken up without you having to do lots of physical labor.
That sounds great. Less physical labor, the better. Brilliant.
Yeah.
Right,
So,
shall we have a 5-minute break, and then we'll
please.
come back at 7:30.
Perfect.
See you all then.
So the question about does the term poor soil imply either sandy or clay? I think often people refer to poor soil could mean that it's very sandy, so it doesn't retain nutrients or water. It's more likely to refer to the sandy soil for those reasons. But I generally think it means that there's very low nutrients and free draining. So the opposite of that might be a rich soil, which would usually be a clay soil with lots of organic matter, which is going to have lots of nutrients and lots of water holding capacity. And those flowers that you bought there are going to be really, really beautiful. And they've got their niche in that kind of poor soil environment. And the opposite of those in a really rich soil is when you get really fast growing aggressive weeds, like I say weeds, but stuff like nettles. We only, again, to emphasize, the term weed is just a plant growing in a place that you don't want it. Nettles are amazing for nature, but they love really rich soil. So they would crowd out the stuff that otherwise thrives in lower nutrients. So that's why those plants grow in lower nutrient areas, so that they get their space. So yeah, sandy soil with as little nutrition as possible. So you wouldn't want to be integrating compost into that, for example, because the compost is going to have lots of those nutrients, and you get stronger growing plants. Does that help?
I hope so. I did realise that perhaps Aid and Jen weren't back yet when I got you to answer their question. So hopefully they heard that.
Thank you, I did. I really appreciated it. It was brilliant. Thank you, Alex. Cheers.
Thank you. I hope so. They're going to be beautiful.
Oh, thank you.
Does anyone else have any quick questions?
Can I just ask a quick question? Sorry, Alex. It's Amy. I just wondered, is that your quote, or is that a famous quote? A weed is a plant growing in a place you don't want it? Because I think that's lovely.
Yeah, it's definitely not my quote. It's kind of you hear a lot in kind of nature conservation, people talking about kind of reframing how we view plants. And a lot of our native plants we would refer to as weeds, but because they're so common, and we maybe want something a bit more exotic, something that is a bit more unusual. So we would refer to our native plants as being weeds, but actually what grows well is good for our environment. I see, is there a hand up there? Did you have another question, Sally?
Yes, thank you. So I've got an allotment, and the soil looks as though it's got a lot of compost in it, but it doesn't seem to grow that well. So it doesn't seem to grow amazingly. And the main thing is when I do dig it, there really aren't very many worms. This is in Bath.
So it would be helpful to kind of that could be something of lots of different things. So when you say it seems to have lots of composting, what signs are you looking at? What can you see there?
Well, there's very few stones, and it appears to be kind of a deep layer of organic matter, or appears to be. Maybe I'm misinterpreting it. Interesting.
It could be lots of different things. There's lots of very specific climate things. There's kind of broader horticultural things that you might need to think about that without seeing the site specifically. You could do get a testing kit online to look at stuff like specifically nutrients. So it could be that it's a loamy soil, but it's actually, maybe, I don't know if it's Bath, it could be on a hill and everything's all the nutrients are washing out. It could be organic matter that's kind of woodier and not necessarily broken down. I can't really say specifically, but in terms of growth, there could be quite a few different horticultural things going on there. But I can put my email address on the in the PDF that I'm going to send. You can send me a question with some pictures, and we can chat about it.
Okay, thank you very much. But that's a start anyway. Yeah. Okay. Cheers.
Yeah. Am I sharing at the moment?
No, you're not. Let's do that again. Oh, here we go. Yes, you're sharing now.
We'll jump on to talking about compost, because it does link quite nicely with that last question. It's about kind of organic matter and kind of what is compost. So linking everything that we just talked about the mineral content of the soil, and actually it's life that we need in our soil. As an organic gardener, what's really important to me is that we're not using inorganic fertilizers. We're using organic-based feed when we're feeding our garden. And compost is the perfect thing to feed our garden, especially when it's come from your garden. And everyone can compost. Oh, actually, I just want to refresh that. By the way, there's a task 1 for the weekend is you must go test your soil. And so the PDF will come tomorrow, and you need to have a close look for worms. So my favorite film, The Lion King. When we die, our bodies become the grass, and the antelopes eat the grass. And so we are all connected in the great circle of life. And we can spend the next half an hour doing a sing-along if we like, but we'll talk about compost, because composting is the circle of life. Anyone can compost. If you've got a big garden, a small garden, or no garden, this is something that you can do at every different scale. But basically, composting is a product of the natural recycling of organic material. It's a biological process where organic matter is converted from dead organic matter, so all plants, our food waste, stuff that was living that is no longer living, and it's on its way to decomposition, is then converted into humus, which I'm always going to pronounce as hummus. And in that humus is the minerals and nutrients converted to plant form, but it's a dynamic, living, constantly flowing material. So it's not a set material ever. It's constantly in flux, and it's constantly alive, and it's full of life. and it's full of life at every different scale. So again, anyone can compost, and there's a system that's appropriate for everyone, but ultimately it's the same thing that's going on. We're taking something that was alive, we're producing the right environment for living organisms to then convert that into something that is then going to feed our plants and to feed other organisms. So if you've got a big garden, you produce lots of green waste, you're probably going to want a big compost heap. This is an example of 3 bays. It can also be the cheapest way to make a compost heap because you can just use pallets. To get yourself 4 pallets, tie them together with some string, and you've got a compost bay. If you want to be fancy, you can take 3 pallets, bolt them together, and you can keep the 4th one as a door. Cheap and easy, or they can be really beautiful and expensive. This is my friend Charles Dowding and his famous compost bays. He's gone quite fancy. He's got a roof because he wants to control how much water goes in there, and they're massive. And he's got this amazing layer you can see here. You've got green material that's been put on the top. There's a little circle in there in the middle next. That's a little compost thermometer. And you can already see that it's gone all brown below it. Charles does so much composting and he puts so much food onto his compost heap that it gets really, really hot really, really quickly. And that thermometer will be reading 65 degrees centigrade. And that is purely the heat generated by the biological life of bacteria. So if you have lots of material and you pile it up really quickly, it can go from ambient temperature to 65 degrees centigrade within 24 hours. That's purely the energy of life happening. And it's just really exciting to see when you see a hot composting bay. In a more moderate garden, this is what I'm going to get from my garden. I have a medium size. I'm quite lucky that I do have quite a big garden in our back garden, but it's kind of a manageable, narrow, slightly long garden for a mid-terrace house in Bristol. Something like this, which people call a Dalek, is ideal for us. We're not going to produce loads of compost. It's neat, it's tidy, it keeps it compact together. You can get really fancy ones. So the one on the left is a tumbler. So you put your green waste in there and your food, and it makes that your green materials, which is your food, and then your brown materials, which is woody items like wood chip, and then you roll it. And by rolling it, you're aerating it and you're producing lots of oxygen because it's a living process. And we need oxygen, we need food, and we need water, exactly the same as our soil. On the right is basically a fancy version of my Dalek, but it's insulated, so it keeps the heat in. So when the microbes are breaking down the stuff that you put in there, they generate heat. The heat speeds up the process. And by having it insulated, it maintains the heat and it speeds it up. The Dalek, you can, if you're lucky, you can get them for free. You can see them on Facebook Marketplace for £5, £10, maybe 20. You can buy them new for around 50, but keep an eye out. People often give them away when they're moving house, or maybe they haven't managed to make good compost and they've decided that they don't need it anymore. But you're going to make great compost, and the Daleks are great for that. The tumblers on the left are really, really good if you're doing food waste, because one of the rules that we think it's helpful to remember is to avoid putting too much kitchen food in your compost, because what that can attract is rats. By having a raised compost like that, they can't get in there, but also because you're rolling it, you're creating lots of air, it breaks down really quickly. So you can have basically free or slightly fancier, but they're doing the same thing. A slightly different way of composting is worms. I love worm composting. It's super, super easy. You can buy slightly fancier worm farms like the one on the top right. They're really beautiful and you wouldn't necessarily know that it's a worm farm. So you might call them a wormery or a worm farm or a worm compost bin or a worm bin. On the left, you can see slightly half on shot. It says worms for peace, I think. And that's from an organization called the Urban Worm. And they sell really affordable, compact worm bins. And I would certainly have my worm bin next to my bookshelf or on my bookshelf. But you can see how simple they are, because on the right, you can see the components that have gone into it. So making your own worm bin, super, super easy. Worm composting is slightly different from this sort of composting, because on a system like Charles got there, bacteria is mainly doing the work. On a worm farm, you've basically got a pet. You're looking after worms. They are a living, excuse me, it's literally a living pet that you need to look after. So it's a living process. I've said that word many times, but this is one of the reasons why making compost and putting it on your garden is so great, because it is the perfect place. It's basically a bioreactor for the life that you want in your garden. You're starting that circle of life from the single-celled organisms all the way up to the larger invertebrates and bigger animals. Every time I look at my compost heap, I find a slow worm. The slow worms are feeding on the worms and the slugs. The worms and the slugs are feeding on the bacteria and the invertebrates and the woody material and the organic material. Yeah, it starts with our bacteria, and we got a beautiful, really, really beautiful slow worms. But you might also find hedgehogs hiding out behind there. It's basically the perfect environment, because it's a canteen for all of our favorite animals. And when you take that compost that you've made in your compost and you put it in your garden, you're seeding your soil with microbacteria. Hopefully you've got some worms in there. You're probably inadvertently spreading all those invertebrates out into your garden, and you're seeding your garden with life. Again, anyone can make amazing compost. And we've all probably, anyone who's probably tried to make compost in the past, it can be quite tempting. You throw it on there and you expect it to happen. It doesn't necessarily happen automatically. It is something that you need to kind of think a little bit about, because basically it is a living thing, and we need to make sure that it's got food, we need to make sure it's got water, and we need to make sure it's got air. So we're back to our same principles as our soil. So when we think about the food, everyone might have heard about greens and browns. The greens is nitrogen. That's everything that's kind of green and wet and fresh. So we've got our food at the bottom, grass clippings at the top right, maybe the weeds that we're clearing from our garden. A good example at the moment about a weed is dandelions. Dandelions are in flower at the moment. Really, really important early pollinator flower. So dandelions in our lawns, super, super important. But also dandelions have a really strong, deep taproot. And what they're doing is breaking up the soil structure. So dandelions are actually a really important plant in our native habitats and native garden in our gardens. So when we are clearing our weeds and clearing stuff that we don't want, that can go into our compost. But that's our greens, and the greens are basically the nitrogen, but I like to refer to them as kind of the wet material. That's where our water comes from.
Oh, Alex,
Yeah.
Maybe this is a good time to interrupt you. Quite a
Yes,
few
please.
questions in the chat.
Yes, sorry.
Also, you can get a Dalek for £22 from Bristol City Council, Marianne says, which is brilliant.
That's brilliant.
But I think the most relevant one is, we're talking, Mo wanted to ask, is it a bad idea to put things like ivy, couch grass and other things that spread quickly in the compost? Like, it'd be interesting to hear more about like what we shouldn't be putting in terms of perennial weeds, and maybe like the rat thing that we talked about. And then Aidan Jen said, should we worry about hot compost with heat waves like last year, like whether it could possibly be a fire risk?
So we'll deal with what not to put in there first of all. If you are getting your compost really, really hot, so you're layering it up really efficiently, which we'll talk about in a moment, and you've got lots of air pockets in there, and it's all coming to life, the heat naturally kills all those weeds. It kills all the seeds, and the compost that you buy, green waste compost that you buy, the way that they make sure that it's clean and not full of weeds is because they aerate it so much that it gets really hot and it kills everything. At home, that can be quite hard. So I would be tempted to suggest to avoid putting anything that is likely to have a root that's going to come back. So those are often really, really strong looking white roots. So your couch grass, bindweed, etc., because then you're going to be spreading that out. On the other hand, I would say you've probably already got those things. And if you're not making compost because you don't have enough green material, put those things in there and make some compost. But yeah, maybe I'm a glutton for punishment, and I'm going to be pulling up bindweed for the rest of my life. So as a precaution, I'd say no, avoid putting anything that you think is going to be really vigorous. Definitely, even in a hot compost system, you wouldn't ever put something like Japanese knotweed. If you've got knotweed, you know about it anyway. But even in a hot compost system, you shouldn't be putting that in there. Otherwise, in a hot system, you can, but as a precaution at home, don't. What's the other question? Sorry.
Is there any chance that a compost could be a fire risk?
In a hot compost system, I definitely wouldn't worry about it. It doesn't get that hot that it's going to combust. That did used to be a thing when people used to build hay ricks for all the old hay. So you'd harvest your hay and then you stack them up, and when you make your hay rick, it should be really dry. And so the hay is preserved because it's too dry to it won't start to compost. It won't break down because it's too dry. But if you build it really badly and water gets in, then it starts to heat up, and the heat and then the dry straw on the outside can be a fire risk. So people who used to build hay ricks, if you could build a hay rick that wasn't a fire hazard, you'd get paid a lot of money. It was a skilled job. Composting wise, that's not something you're ever going to need to worry about. It's a self-regulating thing because it's the bacteria that makes it hot. And if it gets too hot for them, they die, and then the heat starts to drop. And unless you have lots of very, very dry tinder on top of it, it's really unlikely that anything could catch. Cool. Is there any other question?
Yes, I'm slightly conscious of us running out of time. We've only got 5 minutes left. So maybe we should, there's a couple of questions here about worms, but I think maybe we should, oh, hello, we're coming on to them. Jan wanted to know whether red worms are particularly attracted to compost making. Sometimes they try and get out. Is that okay? And then Amy worries about digging them up and putting them in tubs because she feels guilty about restricting their movement. So it's nice that we've got a lot of care for these worms. So yeah, anything about kind of like keeping the worms healthy and alive, I guess, would be useful.
Okay, brilliant. If anyone has any specific questions about kind of building a good compost bay, we hope to be running some hands-on composting workshops at Grow Wilder at some point. But because I've been moving and little baby, we haven't sorted out any dates yet, but keep an eye out on there. I'm talking to the Grow Wilder team because we'd love to be doing some hands-on composting on site, because it's a really good thing to do on site. And any questions specifically about your compost bays, send me an email. That'll be in there. But worms, really quickly, because we are running out of time, and I apologize, it's a lot to fit in and I get really excited. So there's two types of worms that do composting, and you can see them kind of in this image there. The really red ones, their kind of nicknames are kind of the red wrigglers, And then there's kind of the tiger worms, which have a really distinctive kind of yellowy stripe. They're kind of brown and a stripe, and you can see both of those in this picture. Those are the two types that specialize in composting because they love to eat fresh material. They love to eat fresh food. If you find a worm in your soil and then you move it to your compost bin, it's probably going to then try to escape because that's not where it wants to live. But if you have a compost bin like your Dalek, you'll find loads of these types of worms in there. Those are the sorts of worms that you can then put into your tub as a worm farm. But the most important thing to remember when you've got your worms is that it is literally like keeping a pet, and you need to think about how they eat. So they don't have teeth, they have tiny little mouths, and they produce lots of water. As the food breaks down, it produces water as well. So you have to remember that if you build your own compost bin, worm farm, and there's a link here to the Natural History Museum for a really, really easy way to build a nice worm farm. I've done this and it's brilliant. You need to make sure that there is either drainage at the bottom, like a tap that you can put in at the bottom, which is, you can see in this one here on the bottom left there. So a tap to make sure that the liquid is being drained, and you have to chop up the food before you feed it to them. So you want to be feeding it, and they're quite not fussy, but there's certain things that they don't like. So feeding them green leaves like lettuce, you have to chop it up because they can't really do it themselves. So if you find a worm in your garden, transferring it to the compost bay isn't necessarily a beneficial thing to do. But if you find a worm in your compost bin, then you can transfer that to a worm farm, definitely. Is that helpful? So there's a link there in this slide here, but also PDF to the Natural History Museum. And basically taking these tubs, and you drill some holes in the tubs and they stack. And so you don't need to have a tap. You put the bricks in at the bottom, so the second tub sits on the brick, so there's a void below it where the liquid builds up, and you just need to remember to empty it occasionally, and you can make a really cheap big worm farm. And basically everything that comes out of a worm is good. Nothing bad ever comes out of a worm. So the compost that you get from a worm farm or a worm bin is the highest grade compost. And if you mix that in with your seed compost, for example, it's full of good bacteria, but also hormones which promote plant health and plant growth and seed germination. So you get much healthier, faster growing seedlings if you've got vermicompost in there. And it's kind of like having something like sauerkraut or kombucha for the human microbiome and the gut. It's the same sort of idea that you're feeding your plants with this amazing good bacteria in the early stages of its life, and it promotes healthier life for the rest of its life.
Alex, there's a couple of requests.
Yes.
I think we skipped over a couple of slides around what we put in alongside the greens.
Yes. So to go with your greens, you need to put the browns in, and the browns are basically the dry things. That's the carbon. So dry things are stuff like, so again, stuff that used to be alive but is now no longer alive. So cardboard, wood chip, brown leaves. And basically the carbon is the food source, and the nitrogen, the greens, is the fuel. So that's kind of, combine those things, the bacteria break down the greens and the browns, and they mash them together into a new product, which is the humus, which is basically all the nutrients and all that carbon, and it's recycled into a new product, which is the humus, which is then what we put on our ground, which is what compost ultimately is. And that's a mixture of the living organisms, the carbon in a new plant available form, and basically full of life. And that's when you look at this picture here of Charles Dowding, you can see that it's underneath that green layer, it's a brown layer, and that brown layer is the humus. That's the the color comes from humic acid, which is a amino acid. And when you look at healthy soil and you see it's got a nice dark rich color, that's what we're looking at. It's the organic matter, it's the soil organic carbon, which is what feeds our ecosystem. So composting, if you get those two, sorry, I'm jumping back and forth because I'm rushing. Composting is basically like making a lasagna, where this is a nice vegetarian lasagna, where the green material is the kind of the veggie lasagna in between, and then the sheets are our brown material, because our compost bay wants a nice mixed healthy diet, and it's helpful to remember that we just feed it lots of one thing, it's not going to thrive. So it needs to have nice layers. So in our lasagna metaphor, the mince, the veggie mince in the middle is our greens. Then we put a layer of browns, then we put a layer of greens, then we put a layer of browns. So really quickly, what I would do is I would keep a collection of brown material, because that's dry, it's not going to go anywhere, near your compost bin. So in a shed, or undercover by the compost bin. And then whenever you do something in the garden, which involves maybe doing a bit of weeding, or you've got some food waste that you want to put in there, so stuff like raw, uncooked vegetables, banana peels, apple cores, etc., or your grass clippings, you put that in a layer. Then you've got your browns right by the bin, you put that in a layer, and then you can walk away, and then next time you come, you put some more greens on top, and then the browns on top of that. And then that basically produces the right environment for feeding that ecosystem of decomposers that then produce the compost. How are we doing for time?
We are pretty much out of time. It is bang on 8 o'clock. How much more did you have?
That's it. I just want to tell everyone to their task is to think about where they're going to put their compost bin next to their wildlife pond, because we're going to have dead hedges and wildlife ponds and compost bins in our garden. It's going to be great. So task 1 is to go and have a look at your soil and I've got a little bit muddy hands, get your hands messy, get tactile with the soil, smell it. If it smells sweet, if it smells fresh, it smells good, it's healthy. If it smells bad, it probably, if something's wrong there, and you can kind of think about that. And the second task is to think about, where can I put a compost bay? Because composting is brilliant. And from an organic grower's point of view, it's about feeding our soil, feeding our plants with good, with nutritious food. It's a healthy diet that we're feeding our ecosystem. And that's basically where I'm at. And a big thank you. And we can have thriving gardens like that.
Thank you so much, Alex. If you want to unshare your screen, you can see all the lovely comments that are coming in. I think everyone's found this really, really helpful.
I hope so.
Yeah, I'm gonna draw it to a close, but I know we haven't managed to answer every single question here, but Alex says he's going to share his email address.
Yeah.
And just to remind everybody, next week, I believe we're talking about wildlife friendly food growing, which is going to be super cool, super interesting. And I've just put a link into our wildlife gardening competition. All of you should enter. Even if you don't win, you get a cool poster to display in your garden to say that you've got a wildlife friendly garden. So that's enough in and of itself. But yeah, thank you very much for everyone, and
thank you so much, everybody.
We'll see. Is there anything you want to plug or tell anyone about before we go, Alex?
If you've enjoyed talking about soil in this last hour and a bit, come think about joining the Grow Leader course that we do at Grow Wilder. I do a whole day on this, and we can all get hands-on together, and we dig some soil up, and we look at different environments around Grow Wilder. The course is a really inspiring course. It is a bit of an investment, but it's definitely well worth it. But also just check out the events going on at Grow Wilder, because if you're in Bristol, it's just the most inspiring space, and the team at Avon Wildlife Trust just do amazing work. So if you're not already a supporter, do it, because they're brilliant. And I don't work for them. I just think it's brilliant.
Thank you very much.
That's great, Alex.
Really
Thanks a
good.
lot.